So first of all, we will know what do you mean by the exact terminology concurrency. Why this term concurrency? Okay, so I have written this point. The ability of a program to execute multiple tasks simultaneously. That is called as concurrency. So the meaning is concurrently or simultaneously executing multiple tasks. The program which is doing this, so that is representing concurrency. So this term basically based on the concept of multitasking. Multitasking means what? Executing multiple tasks simultaneously. That is known as multitasking. So first of all, we have to know what is multitasking, and there are two types of multitasking. One is a process based multitasking, and thread based multitasking. So this thread based multitasking is known as multithreading. Suppose I am downloading a file. At the same time, I am writing a program. At the same time, I am listening a music. Writing a program is a task. It is a job. At the same time, I am listening a music. That is also a task. So when I am writing a Java program, Java related process is going on. For this operating system allocating resources, the entire helper components, that means Java compiler, linker, loader, assembler, header, debugger. So all the components are active. So that is a task. Operating system allocating a time slot. So within a specific time slot, you have to complete your task. So at the same time, you are listening a music. For listening music, suppose you have installed VLC media player. So an application is running. Operating system also allocating resources for that task. So this type of multitasking is known as process based multitasking, because writing a Java program, for that a separate process is creating. Separate memory is allocating by the operating system. So simultaneously, suppose two process creating. So for this, we can say this is process based multitasking, executing multiple tasks simultaneously, where each task is a separate independent process. This is a Java program writing. So this is you are listening music. Simultaneously it is executing, but actually it is not simultaneously executing. I will explain how it is executing, but it is seems like. So that's why it is called as process based multitasking. But in thread based multitasking, so program is one. In thread based multitasking, program is one. If program is one, so process is one. To run a program, a process is creating, but task is multiple. So this is one task. This is one task, and this is one task. T1 representing a job or one task, T2 representing another task, T3 representing another task. Suppose T1 representing 5 times high, it will print. T2 representing 5 times hello, it will print. T3 representing 5 times Java programming, this message it will print. But program is one, process is one, operating system allocating time slot once, operating system fixing resources, allocating resources once. Each task sharing all resources, whatever the resources allocating by the operating system. So this type of multitasking is known as thread-based multitasking. So the thread means a task or a job. Multiple task means multiple threads executing simultaneously, but program is one in a program. Process is one. Memory allocation once. Resource allocation once. So this scenario is known as thread-based multitasking, and in our context, this thread-based multitasking is known as multi-threading. So executing multiple tasks simultaneously in a program, so is known as thread-based multitasking, and it is suitable especially in programmatic level. So this is known as multi-threading. Actually, how it is executing, that part also you have to know. Suppose, let I have one task T1, let I have another task T2, let I have another task. Suppose, let suppose this is T1, let this is T1, this is T2, and this is T3. Let operating system allocated 1 millisecond. Suppose. So time slot operating system is allocating. So that means within 1 millisecond, T1, T2, T3 have to complete its execution. Then definitely T1 will take 1 by 3 millisecond. Similarly, T2 will take 1 by 3 millisecond. T3 will take 1 by 3 millisecond time. So within 1 by 3 millisecond, T1, T2, T3 will complete its execution. Now T1 started its execution. Later on, I will explain each and every thread having a priority. Okay, so a priority is a terminology. So in this way, T1 took 1 by 3 millisecond for completing its execution. Similarly, T2 and T3 took 1 by 3 millisecond for completing its execution. What I was telling about priority. So priority is an integer value ranging from 1 to 10, an int value. But priority, if explicitly, if we are not specifying, then every thread what will contain the default priority. Default priority is 5, you remember. Let it, that part I will explain in later. So now T1 started its execution. Let T1 representing one task, T2 representing another task, T3 representing another task. T1 representing like 5 times high, it will print. T2 representing hello 5 times, support T3 representing Java programming 5 times, it will print. Now T1 started its execution, then within 1 by 3 millisecond, T1 have to complete its execution. If within 1 by 3 millisecond, T1 is not able to complete its execution, then the control will switch over to T2. So if within 1 by 3 millisecond, T1 will complete, then it's okay. Then happily the control will go to T2. If within 1 by 3 millisecond, T1 is not able to complete its execution, then control will switch over to T2. Then T2 will start its execution. Suppose T1 5 times high, 3 times suppose high it have printed, then T2 output came. T2 output came. Hello, hello, T2 output came. That means after 3 iterations of T1, after 3 iterations, the control have switched over to T2. So in which time control is switching over? So that is abstract. So we cannot know. But how we are knowing? After getting output. From the output, we will observe. Similarly, so within 1 by 3 millisecond, if T2 will complete its execution, then the control will go to T3. If within 1 by 3 millisecond, if T2 is not able to complete its execution, then control will switch over to T3. Then T3 will execute same way, and after T3 execution, then the control will see is there any time is remaining, because total time is 1 millisecond. So if the time is remaining, then the control will go to again T1 for executing remaining portion. Then control will go to again T2. So in this way, the control switching over to from one thread to another thread. So this is called as context switching. Remember, there is a terminology, context switching. The control switching over in multi-threading execution. Okay, in multi-threading execution or multi-threading executing through context switching. Through context switching. That means the control is switching from one thread to another thread at the time of execution. At the time of execution. So this is called as context switching. So in multi-threading example, we cannot give the guarantee in which order the output will come, because suppose currently I told after 3 times high, then T2 output is coming. After getting output, we can observe. So I hope everybody got clarity what is multi-threading and what is context switching. Okay, then simply you remember, in every Java program, there is a default thread that is running, and that thread is called as main thread. Let class name, suppose let my class name is thread demo. Suppose currently I told every Java program has a default thread. Every Java program, that thread name is main thread. That thread name is main thread. Then question is how I will get that current thread, how to get current thread. So what I wrote, thread T equals to, I will explain, thread dot current thread. Now I will write an output statement system.out.println T suppose. So what is this? You remember thread is a built-in class name. You remember thread is a built-in class name. You see in the right hand side what I have written. Current thread is a built-in method. It is invoking by thread class. In Java programming, you remember generally method is invoking by an object. In which cases method is invoking by class. That method is a static method. You remember when a method is directly invoking by a class, so that method is a static method. So I'm not going in detail towards static method. It is a point of Java class and object. So current thread is a static method because it is invoking by thread class. It is returning same class object, thread class object. Now I want to print the value of a T. So that T representing current thread. T means the value of T. We will see. Now I will save. So I will go to A drive. Any folder I will save. Let it Java programs. So program name is always we have known class name dot Java. So here my class name is thread demo. Okay. Now save as type. I will do all files and I will save. Okay. You remember? So I hope you all have known every Java program is nothing but a class. So program name is class name dot Java. So definitely I will go to command prompt. I will go to A drive, go to Java program. So here I have saved my program. Then now I will compile Java C. What is the command for compilation? I hope you all have known Java C space file name thread demo.java. Okay, so compilation is successful. Now I will run Java space class name. So thread demo. You see what I got the output thread. So within square bracket hash 1 then main comma 5 comma main. This one hash 1, this is the thread ID, uniquely identifying a thread JVM is providing. Main, this main is the thread name. Currently I was telling, so in every Java program there is a default thread which is running, that is main thread, and 5 is the default priority of the main thread. Default priority or normal priority of a thread, that is 5. Then last main is thread group. There is a thread group. That thread group name is also main, where main thread is coming. So in this way, or this is the explanation of the output. Okay, so I hope everybody got clarity. So this is the way that we can get the current thread, and current thread or default thread is main thread. The priority of that thread is 5. But our objective is not that. Our objective is we will create user defined thread. I will go to next example, how to create a user defined thread. Okay, so multiple threads we will create. So there are two approaches to create a thread. First approach is create a class, create a class which extends thread class. So this is the first approach. So our objective is how to create a thread, create a user defined thread, our thread. So what I told, there are two approaches. This is one approach, create a class which extends thread class. Extends keyword basically meant for inheritance. Suppose I can write class, let class name extends, let class A, class name extends thread class. So now I can say A is a subclass or a child class, thread is parent class. So this is the concept of inheritance. I hope you all have known. So what I told, create a class which extends thread class. Now a thread representing a job or a task, a thread representing a job or task, then how this thread A, now A is the thread name, or a thread is a child class, or a thread is a subclass. So the concept told, to fully define a thread, to fully define a thread, we have to define a method. It is mandatory. So that method is run method. Run method is a built-in method. Basically, it is an overridden method. Overridden method because this run method coming from thread class. Also, this run method available in runnable interface. So this method already available in thread class. Your thread class is a parent class. Parent class method and child class method. Same method again. I am defining in child class. So that's why I will consider this method is an overridden method. Now I will simply I will write a code for int I equals to 1, I is less than equals to 5, I plus plus. Simply one for loop. Just I am writing simply one message I want to display 5 times. System dot out dot println. Suppose I will write hi. So now A is a thread. So from this to this, so we can say this is the fully definition of a thread, or we presented a thread, and run method definition representing the job, the task. So what it is representing, 5 times high it will print. Similarly, if I will create another thread class, B extends thread class. Same way, I will define public void run method for int one loop. I am taking j equals to 1, j is less than equals to 5, j plus plus. System dot out dot println. Let I will write hello. This. So here we can say A is a thread, B is a thread. The thread A representing 5 times high, I is equal to 1, 1 is less than equals to 5, condition is true. Body will execute high, it will print, then I plus plus 1 plus plus, that is 2, then control will come to this, 2 is less than equal to 5. So I hope you all have known in what is the for loop mechanism, in which way the control treat for loop. So this is 5 times high and this is 5 times hello. So A thread representing 5 times high, it will print. B thread representing 5 times hello, it will print. Then I will go to main method, because without main method, Java program is incomplete. Let's suppose thread example 1. My class name is public static void main. So string args. Okay. Now this line is the object declaration line. So we have two child classes or two subclasses. One is A class and one is B class. But in this context, A class is our thread, B class is our thread. So now I will create the object of A class, I will create the object of B class. Let I will write, we know that how to create an object name equals to new class name. Let one object I am creating of A class be obj2 equals to let new B. So now obj1 is the object of A class, obj2 is the object of B class. Object, it is a dynamic memory area which is containing class property. Obj1, which type of object? A type of object. A is a class is a type. So I hope you all have known simple class and object concept. Or basically in this context, we say obj1 is called as thread instance or obj2 is called as thread instance. Now, after object declaration, then I will call the method, because run method I have defined. Then how run method definition will execute. So the concept is saying obj1 dot start method for executing a run method definition. Another built-in method we have to call by the object, that is start method. Similarly, I will write obj2 dot start method. So why start method? Maybe question will arise. Maybe interviewer may arise this question. We know that once a method we are defining, that method I will call by the object, then method definition will execute. Why I will not write obj1 dot run method? If you will write obj dot run method, obj1 dot run method, or obj2 dot run method, there is no problem. Then if there is no problem, then why we are writing obj1 dot start method, obj2 dot start method? The reason is, if I will write obj1 dot run method, it is not representing multi-threading. In case of multi-threading, a separate, you remember this is very important point. In case of multi-threading or in multi-threading context, a separate runtime stack is creating. Let this is one stack, this is one stack. Suppose this stack is containing A thread information, this stack is containing B thread information, or there is also a main thread. So this is called as multi-threading. Again I am repeating, in multi-threading context, a separate runtime stack is creating. Okay, and each stack containing each thread information. But if you will call obj1.run method, so why I told that will not represent multi-threading, because only one stack in that case will create. This stack will contain main thread information, A thread information, B thread information. One stack will create and it will contain all information. So this is not a multi-threading. This is a multi-threading. Okay, this point you remember. interviewer may arise. So there is a relation between start method and run method. So when start method is invoking by the object obj1, obj1 is the object of a class, then control will go to a class run method definition execution. This part will execute. Similarly, when start method will invoke by the object obj2, then obj2 is the object of b class, then b class run method definition will execute. Okay, so in this way, but we will see in which order the output we are getting, because currently we knew multi-threading program executing by context switching. One thread is executing, so at the time of execution, control may switch over to another thread. So we will see. First of all, I will save this program. Now we have three classes. One is A class, B class, and thread example one class. So program name is class name dot java. So which class name I will give? So this class name, because in this class main method is present. So in which class you have specified main method, that class name dot java is my program name. So now I will save. So class name is thread example one dot java, and I will do all files. Then I will save. I will go to command prompt, then clear screen, Java C thread example one dot java, then Java space class name for run thread example one. So you see, so happily we got five hi, five hello. It may vary from system to system. Okay. So again, I will check. Okay, you see, when again I executed, two times hi, then hello came, then three times hi came, then two times hi. That means thread A have executed. After two iteration, control have switched over to T to B thread. After B thread execution, again control have come to A thread. So, in which order the output is coming, we cannot give the guarantee, because execution, multi-threading execution is happening through context switching. So I hope everybody got clarity. So this is one approach how to create a user defined thread. So this is, we can say it is a multi-threading program. So here also we can set the priority. Currently, I was telling about a terminology, that is priority. Priority. Every thread having a priority. Normal priority or default priority is 5. Minimum priority is 1. Maximum priority is 10. After thread instance creation, obj1 is the thread instance, because A is thread, B is another thread, or A is a subclass, B is a subclass. In this context, we can say A is a thread, B is a thread. That's why I told obj1 is the instance of A, obj2 is the instance of B, basically that is called thread instance. So before start method invocation, I can set the priority. In obj1 dots, there is a method set priority method. Set priority, suppose I will give 6. Explicitly, we can set the priority of a thread. Suppose I will write obj2 dot set priority. I will write, so suppose 9. I will write 9. Now I will set. So obj2 representing higher priority. obj1 representing lower priority in comparison. Okay, now we will see in which way the output is coming. Java C thread example 1.java, then Java space class name thread example 1. You see, so first hello, hello, hello. First, that means B thread execution have done. From the output we are observing. So B, why B thread execution? Because obj2 dot set priority within bracket 9 we have written obj2 is the object of B thread. So B thread priority is 9 we have set explicitly. A thread priority is 6. So higher priority thread executed first. From this output we are observing. We will see again, suppose I will run Java space thread example 1. Same output we are getting. So what we are observing from this output, higher priority thread executing first. So I hope everybody got clarity. This is multi-threading representation. Then we will go to the next point. Another approach to create a thread. So that is create create a class which implements a runnable interface. Implements Minty for interoffice, extends Minty for inheritance. If you see extends keyword we are using, so that is representing inheritance. Implements keyword we are using, that is representing interoffice. So runnable is a built-in interoffice. So what I told, so create a class which implements runnable interoffice. Runnable interface. That means we can say a thread is an implementation class. But in approach one, we can say thread is a child class, a thread is a subclass. But here in approach two, a thread is an implementation class. Same way, suppose class name, let class name is my thread, implements runnable, runnable. Same way, class name implements runnable. Same way that we can develop the program to fully define a thread. To fully define a thread, it is mandatory that we have to define run method. So without run method definition, a thread cannot define. So since it is an implementation class or overall it is a class, my thread, you can do everything. That means you can take any number of variables, you can define any number of methods. There is no problem. But it is mandatory, you have to define run method. Without run method definition, a thread is not fully defined. This point you remember. Then same point, if I will write for int k equals to 1, k is less than equals to 5, k plus plus. Suppose I will write system.out.println one message. Suppose I will write Java with Silan Software. This. Now, this is the full definition of a thread. And my thread name is my thread. This is user defined. Whatever you can write. In first approach, we have taken A, B. So that depend upon you, whatever you can write. Now, this is the definition of a thread. Run method definition representing task. job. And strictly speaking, run method is an overridden method. Run method available in runnable interface also. Now I will write class. Suppose one class, or that is called as thread I define. Let class thread example 2 public static void main string args. Now I will create an object of my thread class. My thread class name object name equals to new class name. This is called as thread instance. So now I created an object of my thread class. Now we know that after declaration of an object, we can write object name dot method name. So in approach one, we have started obj dot start method, because currently I told to execute run method definition, we have to call start method. When start method is calling, run method definition is executing. That means a thread started its execution. But here, if this line will execute, error will arise. In this context, in second approach, when start method, I will call by thread instance, thread object, run method definition will not execute. Why? The concept is saying runnable interface have no stat capability. If the approach, your class implementing runnable interface, that class object have no stat capability. Only thread class object have stat capability. That stat capability means to start the execution of a thread. A run method definition is executing means a thread execution is starting. So what we will do here, then how in second approach, in this approach, run method definition will execute. So we have to bring thread class object. Thread is a built-in class. Thread t equals to class name, object name equals to new class name. Then thread class object have start capability. So I can write t dot start method. But how, when this line will execute, how the control will go to execute this portion? So this line and this line, we have to create the relationships. How? This obj representing my thread class property. So within bracket, I specified obj. Now obj is the object of my thread class, object containing class property. Class property means within curly bracket begin and curly bracket end, whatever anything is present, that is the class property. So when thread class object I am taking, only additional line, one line extra we are writing, thread class object we are creating. So within a bracket I specified obj. So now this obj containing whatever the property, so that property now the t will contain. Then when t dot start method, it will execute. Now this portion will execute. So in this approach, so this line extra you have to write. Then it is a multi-threading concept. That means one task I presented, another task suppose I will present. Suppose let it, after this, suppose another task, suppose let int p equals to 1, p is less than equals to 5, p plus plus. Suppose I will write Java concurrency. Now this. So after thread instance creation, thread object declaration, again after start method invocation, a task I am representing. So this task is the job of which thread? Suppose this is a task. Run method definition representing a job or a task. This task is the my thread task. My thread task is this. But this task is the task of which thread? You remember in main method, whatever we are presenting a job, so this is the job of main thread. So this is the job of main thread, main thread. Because our task is anyhow I will represent multi-threading. So this is the main thread task. This is the my thread task. Okay, in this way. But control always try to execute main thread job first. We will see in which way the output is coming. So now I will save this program. Program name is thread example 2.java. I will do all files, then I will save. I will go to command prompt, Java C thread example 2.java, then Java space class name thread example 2. So you see first main thread executed, Java concurrency, Java concurrency. Then my thread executed. This is the my thread output Java with Silan Software 5 times. Okay, we will check again. Suppose I will run Java thread example 2. Same output is coming. So what we are observing, so in this context, particularly in this case, first main thread is executing, then my thread is executing. So in a multi-threading program, after getting output, always we will observe in which way Java control is executing. So this is one of the interview question, fresher interview question 0 to 3 years. So how many approaches that we create a thread means user defined thread, and which approach is better and why? Which approach is better? First approach or second approach? Maximum time students will refer first approach. First approach is very popular. This approach is very popular. Then according to the concept, according if we will do analysis, second approach is a better approach. Why? That part interviewer may ask this question. So currently what we got, there are two approaches that we can create a thread. One is create a class which extends thread class, which extends thread class. Then another approach is create a class which implements a runnable interface. This. So which approach is better? And I told second approach is better. Why? You see, in inheritance, suppose this class extending thread class. Now, suppose another class, suppose I will take class B, and if I will write here, suppose I wanted this class A extends thread class and another class also, if I will write, then it will give the error because now it is representing multiple inheritance. Multiple inheritance not supported by Java. One class extends from one class. One class never extends from more than one class. But whereas this class implements runnable interface, and apart runnable interface, any number of interfaces you can add. There is no problem. So one class can implements more than one interfaces, no issue. But one class cannot extends from more than one class. So functionality is less. Here functionality is more and more. So class A extends thread class only. Apart thread class, this class A never extends from other classes. If you will write any class, it will represent multiple inheritance and multiple inheritance not supported by Java. I am not going through what in detail in that part, but here more and more functionality. This class implements runnable interface. Then if you have more than one interface, X, Y, Z, n number of interfaces, there is no rule. So second approach is better, but approach one is popular. Approach one is popular. Maximum time or any time when the representation of a thread is coming to our picture, so immediately first approach we write always. So approach one is always a better approach. So I hope everybody got clarity. Okay, so this is the way that how to create a thread and two approach we saw, and this is also thread example 1.java. It is representing a multi-threading program. Thread example 2.java, it is representing a multi-threading program.